Hi, and welcome to 12.1, the nature of probability. An experiment is a controlled operation that yields a set of results. Outcomes are the possible results from an experiment. An event is a sub-collection of outcomes of an experiment. So, could be all of them, could be a smaller group of them. Empirical probability is the relative frequency of occurrences of an event and is determined by actual observations of an experiment. That's empirical. It's not theoretical, it's empirical. Theoretical, though, is probability determined through a study of possible outcomes that can occur for the given experiment. So empirical is what you watch what happens, like how many times do people make an illegal right turn. And you watch that versus the probability of someone doing an illegal right turn. P of E, what this means is how we'll indicate the probability of an event E, P of E. Empirical probability, or relative frequency, be the number of times event E has occurred over the total number of times the experiment has been performed. The probability of an event is always between 0 and 1 inclusive. Could be 0, could be 1. 1 means it definitely happens. 0 means it can't happen. And someplace in between means there's a possibility. Closer to 1, the more likely. Chase flips a coin 100 times. He gets heads 42 times. Find the empirical probability of the coin landing heads up. So the probability of heads, that's our event, is going to be 42 over 100, which is 0.42. Next one, a pharmaceutical company is testing a new drug that is supposed to help with weight reduction. The drug is given to 500 individuals with the following outcomes: weight reduced in 295, weight unchanged for 102, weight increased for 103. If this drug is given to an individual, find the empirical probability of the person's weight reduced, unchanged, or increases. So for A, the probability of reduction is going to be 295 over 500. That's 0.59. For B, the probability of unchanged is going to be 102 over 500, which is about 0.204. And for C, increase, the probability of an increase is 103 out of 500, which is 0.206. Going on to the next page. Empirical probability. Gregor Mendel, 1822 to 1884, developed the laws of heredity by crossbreeding different types of pure pea plants, and it says pure in parentheses in quotes, meaning they weren't necessarily pure, but what appeared to be pure, and observing the relative frequencies of resulting offspring. The work of Mendel became the foundation for the study of genetics. Dominant would be a trait that will overcome or dominate over other traits. Such examples are dark hair and brown eyes. I got dark hair, I got brown eyes. But I have a child that has light hair, still brown, and blue eyes. Recessive, a trait that will not dominate, there's a typo here, the other, and in the presence of a dominant trait will not be present. For example, blonde hair, blue eyes. So I have actually 2 kids that have blue eyes, and no kids with blonde hair. So we have, in terms of peas, pure yellow and pure green make a yellow that's not pure. It appears to be yellow, but it's not pure because yellow is dominant, green is recessive. Now, in the second generation, if you breed the yellow pea with not pure yellow with not pure yellow, you get yellow or green. There's typically 3 yellows for every green, so 3 to 1 ratio there. If you have a pure round pea bred with a pure wrinkled pea, so this one's both genes in terms of the round are going to be round, wrinkled. You get round but it's not pure, has wrinkled there. If you breed 2 round peas that are not pure round, you end up with round or wrinkled. Again, 3 round for every 1 wrinkled, because wrinkled is the recessive. So the dominant trait, yellow seeds and round seeds are dominant. Recessive, green, and wrinkled. So the number with dominant trait, 6,022. Number with recessive trait, 2001, 3-to-1 ratio. In terms of round and wrinkled, you have 5474 versus 1850. That's about 2.96 to 1. Again, roughly 75% of them have the dominant trait. The law of large numbers, the probability statements apply in practice to a large number of trials, not to a single trial. It is the relative frequency over the long run that is accurately predictable, not individual events or precise totals. So what's the overall pattern going to be? That's what we're talking about. Okay. Well, that'll do it for 12.1. And send me your questions. If you have any questions about the section, we'll meet as a class online. Thank you.